Think about this for a second. Every minute of every day, we're sending hundreds of millions of emails and posting 500,000 tweets. We're not just creating data, we're creating, well, chaos. But what if we could teach a computer to be the ultimate librarian? One that could read, understand, and organize all of that instantly. Today, we're going to look at a really clever new framework that's trying to do just that.
I mean, it's truly a tidal wave of text. Every social media post, every scientific paper, every single patent application just gets added to this gigantic, ever-growing mountain of information. Experts call it a high-volume problem, but honestly, that's putting it mildly. We are talking about millions upon millions of documents, each one packed with countless details. And that leads us to the big question, right? How can you possibly teach a machine to navigate this digital storm? It's not enough to just search for things anymore. It's about teaching it to understand the deep structure of it all, to organize it in a way that's actually useful. How do we find this signal in all that noise?
To solve this, researchers looked to a concept that's, believe it or not, kind of old school, but they gave it a massive modern upgrade. I want you to think of a librarian, but a librarian that works at the speed of light and has to organize the entire internet.
Okay, so the technical name for this is hierarchical classification. And it's actually pretty intuitive. It's like how you organize files on your own computer. You've got a folder for work, and inside that, a folder for projects, then one for a specific project, and then finally, your actual document. It's the same idea, just on a cosmic scale. You start with a huge category like science, then you branch down to biology, then genetics, all the way down to one specific gene. The computer learns to put everything in its proper place on this huge, sprawling family tree of information.
And this isn't just some abstract theory. It is the backbone of how we organize massive, real-world datasets. We're talking everything from web directories to the enormous international patent classification system to classifying gene sequences and even sorting your music library into genres and subgenres.
But of course, it is never that simple, is it? Teaching a computer to be this perfect librarian means you have to overcome some pretty major technical challenges. So let's meet the two biggest villains in this story.
Okay, so here's the deal. On one hand, you've got something called bad collisions. This is when the system, in an attempt to be efficient, just gets confused and accidentally lumps two totally different ideas together. Imagine it filing a patent for a bicycle under the same category as a recipe for a cake. You can see how that would cause total confusion. Then, on the other hand, you have result discrepancy. This is like asking two expert librarians to sort your books. One sorts by author, the other by genre. And when they disagree on where a book goes, instead of figuring it out, they just throw the book out. That's what happens here. The system gets tripped up by its own rules and ends up tossing out perfectly good, relevant information.
And getting this wrong has very real consequences. As researchers pointed out, using the wrong tools doesn't just give you messy results, it actually leads to lower accuracy and costs more time and computing power. You end up with a system that's both dumber and slower, the worst of both worlds.
So, to fight these two villains, researchers came up with a really elegant new two-step solution. And yep, you guessed it, this is the hero of our story.
They call it the Multistage Hierarchical Dimensional Reduction Framework, which I know is a mouthful, so we'll just call it MHDR. And it was designed from the ground up to take on those bad collisions and that result discrepancy problem we just talked about. Now, the way MHDR does this is with two really cool superpowers. First, a technique called modified feature hashing. Think of it as a super smart sorting hat. It doesn't just see a word, it assigns it a term weight to understand its context. So it knows the word bank probably means a riverbank in one document and a financial bank in another, and it weighs them differently. This pretty much stops those bad collisions from happening. Its second power, hierarchical bifiltering. This is like having those two expert librarians, but now they have to work together and agree on which words are most important before anything gets filed. This teamwork builds a consensus, so they stop accidentally throwing away important information.
Okay, so that all sounds great on paper, but the real question is always, does it actually work in the real world? Well, the researchers put MHDR through its paces with some absolutely massive, complex datasets. Let's see how it did.
And yeah, the results, they really speak for themselves. On these charts, the new MHDR method is the pink line, and the old conventional method is the blue one. And you can see, across different huge data sets, that pink line is consistently higher. That means higher accuracy. It's a clear, definite improvement. The new method is just better at getting it right.
But being accurate is only half the story. What about speed? Look at this chart.
That really tall blue bar, that's the baseline learning time for the massive patent dataset. We're talking over 4,000 seconds. Now look at the little purple bar way over on the right. That's the new MHDR method. It's not just a little faster, it's a dramatic reduction. It cut the learning time by more than half. So the system isn't just smarter, it's a whole lot faster too.
In fact, when they looked at the total processing time, the new method delivered an overall speedup of 11%. Now, you might hear 11% and think, is that really a big deal? And the answer is yes, it's a huge deal. When you're processing millions of documents, 11% adds up to saving thousands of hours of computing time, which means saving a lot of money.
So let's zoom out for a second and just look at the big picture here. What does all of this really mean? Well, it's about a pretty fundamental shift in how we can manage this explosion of information.
So why does this matter to you and me? Because it's a real, practical way to turn that text tsunami into an organized, searchable library. This means things like faster, more accurate patent searches, which helps innovators get new ideas out into the world. It means scientists can analyze research papers more quickly, potentially speeding up the next big discovery. And, it really proves an important point. Sometimes the most powerful solution isn't one single magic bullet, but a clever combination of two smart ideas working together.
This research gives us a powerful new tool, a much smarter digital librarian. But that text tsunami we talked about at the start, it's not slowing down. If anything, it's getting bigger. And that leaves us with a really important final question to think about. As our digital universe keeps expanding at this incredible rate, what's the next big challenge going to be? And what new kind of super librarians are we going to need to invent next?